Hi, I'm Curious Vedan, and welcome to season 6 of my podcast. For this first episode of the new season, my guest is Dr. Shan Goh, who is a senior lecturer in microbiology at the University of Hertfordshire, UK. She has done research on projects related to infectious diseases, treatment, or detection. Hi, Dr. Shan. Welcome to my show.
Hello. Thank you for having me.
Yes, this is going to be very interesting. I really like science.
I'm so glad. It's really nice to hear that.
So, Shan, I know that biology is a study of living beings. Does microbiology refer to the study of living beings that are small? Can you tell me more about what microbiology is?
Yeah, absolutely. You are so right. So microbiology is the study of organisms that are small, in fact, very, very small. They are the study of organisms that are visible only under a microscope. So do you know what a microscope is?
Yes, it's this kind of device where it has a eye hole. It's like a binoculars or a telescope, but it's really, really tiny.
Yeah, exactly. So essentially, it's an equipment to magnify objects, right? So that you can see things that are really small. And so microscopes are used to study microorganisms such as bacteria. And this is something that I study. So bacteria is visible only under a light microscope that has a magnification power of about 1,000 times. And if you can, just to help you visualize how small that is, if you take a strand of your hair and you look at the strand of your hair, that width of your hair is about, it's about 20 microns, right? And the average size of bacteria is about 1 in 10 the width of the strand of your hair. So it's really, really, really small. And you really can't see it very well unless you use a microscope. But bacteria is not the only thing that one studies in microbiology. Other microorganisms such as viruses, fungi, and parasites, they also fall under the umbrella of microbiology. And viruses in particular are so small, you can only see it if it's been magnified 10 million times, so there are much more powerful microscopes called electron microscopes that are used to visualize viruses.
Wow, viruses are really, really small.
Yes, they are.
No wonder they can move around so easily.
Yes, exactly. And I mean, so microbiology is not just about looking at the physical microorganisms. We also study everything there is about it, how it's replicating, how it's infecting their host, and the effects of an infection. So that's all very important to microbiologists.
Wow. I didn't know microbiology is so big.
Yeah, it's really a very fascinating subject, I'd say.
Yeah. You did your PhD in bacterial viruses. I've heard of bacteria and I've heard of viruses. What are bacterial viruses?
So, as you know, bacteria are a type of microorganism. And bacteria can cause a lot of disease in humans and animals. But there are also bacteria that are good for us. So, for instance, inside our stomach, in our gut, there are good bacteria. On our skin, there's good bacteria. Inside our nostrils are good bacteria. And these good bacteria can protect us from bad bacteria causing infections. So bacteria are able to grow independently on petri dishes. If you give them nutrients, they can just grow. So that's bacteria. And then viruses, just to give a quick description, is these are even smaller organisms that can, infect different host cells. So we all know, for instance, COVID is caused by a SARS-CoV-2 virus, and the SARS-CoV-2 virus infects our human cells. But bacterial viruses are essentially viruses that only infect bacteria. They don't infect human cells, and they can make the bacterial cells different to what they were before infection. So bacterial viruses are known as phages or phages, and they can either sometimes help the bacteria survive some challenging conditions, or they can kill the bacterial host. So these are sort of broadly the two main outcomes of bacterial viruses. And phages were discovered in 1915 by an English scientist called Tourt, and again in 1917 by a French-Canadian scientist called Darrow. And at the time, well, at least what is generally accepted was that these two scientists had discovered bacteriophages independently. But the term bacteriophage was actually given by Darrow. Both of them discovered that these organisms or phages could not grow independently, unlike bacteria. So what do I mean by independently? Is if they can't grow if you just give them nutrients. They can only grow if they had a host. And in this case, their host was bacterial cells. So this is one of the defining characteristics of viruses, is that they cannot grow independently. They need to have a host in order to multiply.
Wow, that's really interesting. So that means in the COVID test kit, when you have the tube, is that filled with lots of bacteria that multiplies the virus?
No. So COVID so SARS-CoV-2, which is the virus that causes COVID, it's not a phage. So it only infects human cells. So when we're doing these COVID tests, we're looking for the presence of this virus that infects human cells. And if you put SARS-CoV-2 together with some bacteria, the bacteria won't get affected at all, because this virus is not going to be able to infect the bacterial cell.
Wow, I didn't know that. I thought that the SARS-CoV-2 came from animals.
It may have, but remember that animal cells are different from bacterial cells. So they are different things. There can be bacterial cells and there are animal cells, and our cells are closer to animal cells.
Wow, that's really interesting. I never knew that. Why did you choose to study bacterial viruses?
Well, I chose to study them because I had not heard of them before. It was suggested by my university lecturer. So when I was at university, I found microbiology lectures particularly interesting. And the first time my university lecturer mentioned the word bacterial viruses, I was fascinated, because just the idea that bacteria itself could be infected by something smaller was completely fascinating. And the fact that this bacterial virus was so very specific that it will not harm human cells, at the time I felt the potential of that specificity was really quite enormous. And I think that really the thing that finally sold me was when I looked up an image of a bacteriophage. And there's a very well-studied bacteriophage called T4. And when I saw the image of a T4 phage, it looked like something from outer space, honestly. It just looked like an alien, and it looked like something that someone had imagined. And I felt that was amazing that this was not, a fantasy illustration. And I just really wanted to know more about this extremely, different organism.
Wow. Yeah, that also sounds really interesting to me about phages and bacterial viruses. I'm going to search up a T for phage and look at the photo.
Yes, you absolutely should. And I think if you saw it, you would sort of feel the same way as me. Most of my students, whenever they look at images of a T4 phage or some other phages that we've found, they find them very, very fascinating.
Yeah, I'm gonna look it up. I think it'll be really fascinating.
I'm glad.
You talk about anti-microbial resistance. Can you tell me more about that and why it is a problem?
So, yes, of course. Antimicrobial resistance refers to when drugs that specifically kill bacteria, known as antimicrobials, no longer work because the bacteria is able to resist the action of these drugs. So this scenario is antimicrobial resistance. Since the 1940s, when the very first antibiotic, penicillin, was widely used in the Second World War, the resistance to penicillin emerged very soon after, probably within 5 to 10 years. And the same pattern kept occurring for many different classes of antimicrobials or antibiotics that came after penicillin. So now we are in a situation where we have run out of new classes of antimicrobials because they're not easy to find. And everything, all the classes that are approved for use to treat human and animal diseases, bacteria have a resistance mechanism to. So what that means essentially is if a patient happened to be infected by a multi-drug resistant bacteria, they will very likely die from the infection because there will not be any antibiotics that will be able to kill this multi-drug resistant bacteria that is causing the infection. Now, this may not sound like a very big problem because you may feel that that's just one very, very unlucky patient. However, bacteria have this amazing capacity and ability to share genetic material. So they can share DNA. And what this means is they can share DNA that makes them resistant to these drugs. So this sort of ability is quite scary because it means that bacteria can just pick up DNA from a neighboring cell to change their fitness and their ability to survive in the presence of these drugs very quickly. And the DNA that contains these resistance genes, as we call them, it's not limited to one resistance gene. Sometimes the DNA can carry many different resistance genes determinants, and this then increases the efficiency as to how quickly the bacteria can become resistant. It can suddenly become resistant to not just one drug, but 2 drugs or maybe 3 classes of antibiotics, just with one single nucleic acid exchange. So that's why antimicrobial resistance is a problem, because it can spread. And we have to remember that bacteria, there are many bacteria that infect both animals and human. So it doesn't necessarily mean that if it's a bacterial species that infects animals, it will not be able to pass DNA with resistance genes to bacteria that infects humans. So there is also this scary scenario where you have bacteria swapping genes that is between, between species almost.
Wow, that's really scary. Is there a way to kill these multi-drug resistant bacteria?
That is such a good question. So that's what most, I would say, very many researchers are working on, is finding alternatives to antimicrobials, finding a different way to kill these multi-drug resistant bacteria. And one of the ways which I like to think will work is the use of bacteriophages. So phages, because they have the natural ability to kill bacteria, and they kill bacteria in a very different way to antimicrobial drugs. It means that if a bacterial cell is resistant to antibiotics, it may not be resistant to phage. So phages can infect these multi-drug resistant bacteria and kill them. So that's a very sort of, I think that's a dream for, well, not just a dream, but a goal, I would say, for many microbiologists or phage biologists, because that is a very direct and good application of phages.
If scientists can do that, then millions of lives could be saved.
I think so. The situation, though, is not as simple as that, unfortunately, because phages themselves are living organisms. So there's always the possibility that the phage will not do exactly what you expect it to do. And so to use phages as a therapeutic agent, especially in treating human infections, needs needs a lot of research to ensure that it is safe and that the benefits outweigh the risks.
So in a way, that would be you using a virus or phage to kill the bacteria to make us better, right?
Mm-hmm.
Is antimicrobial resistance a problem only for humans, or is it a problem for animals too?
It is also a problem in animals, absolutely. And this is because animals also get infected by bacteria. They suffer from bacterial infections, and animals, as you know, are being farmed for food. And the livestock industry is now has had to expand, and it's expanding all the time in order to produce enough food to feed everybody, right? So because of this expansion, farming has now reached a point where they have to cope with animal diseases in a very efficient manner. And that often means that they have to use antibiotics in the way that you would use to treat human infections. Farmers will have to use antibiotics to treat animal infections, because if one animal is sick on the farm, very quickly it will spread to all of the other animals on the farms. And then the animals, when they're sick, obviously they cannot be sold as food, right? So you'll have to treat them. Now, sometimes in order to prevent an outbreak or to prevent animals falling very, very sick, farmers will have to use antibiotics in a way that can lead to resistance emergence. So what they're seeing in animals now that are being farmed is that they are also being infected by bacteria that are resistant to antibiotics. So it has also become a problem on farms in animals.
So, are there any like vaccines or anything that not only for humans but also maybe for animals that can help cure and kill these, what do you call it, the antibiotic resistant bacteria?
Yes, there are. Absolutely. There are vaccines that are developed to try and protect the animals from disease and infection by antibiotic-resistant bacteria. So there are many sort of the strategies that are used for human medicine are often also employed, in the animal health sector.
Well, I didn't know that. I thought it's two completely different things.
Well, I didn't know that either, to be honest. But when I worked in the Royal Veterinary College in the UK, that was when I interacted with very many vets and vet scientists, and I learned all there is to know about animal health, and it is really very fascinating and very, very interesting what goes on behind the scenes on farms.
I find it really interesting. Among all the things that you do, you are a reviewer and an editor of scientific journals. What does that work entail? And do you need to know a lot of information to be able to review and edit journals?
So as a reviewer for scientific journals, the work is I receive manuscripts written by scientists to look at, and then I give my opinion about the scientific quality and the scientific impact of the paper. And the types of manuscripts that come to me will be in the topics that I am familiar with or an expert in. And this is why very many scientists are also reviewers for scientific journals. This is something that I would say a lot of scientists like to do because one learns a lot reading other people's work. And I then make a recommendation on the manuscript to an editor, to the editor of the manuscript, to say how I feel about this paper and whether I feel that the findings are significant enough and within scope of the journal for it to be published. And usually more than two reviewers are required we form our independent opinions, and the editor then looks at these independent opinions to make a final decision on whether a manuscript should be published. So that's the job of a reviewer. And the editor, as I've described the job a little bit, is in addition to reviewing the manuscript, like you do for a reviewer, you also, you're the person that first receives the manuscript, and after reading it and deciding that it is interesting enough to be sent out for review, you will then find reviewers to look at it. And you need to find reviewers that have expertise in the area of the paper. And then you make a final decision based on the reviewer's opinions. And very often we ask for clarifications from the authors, and sometimes we ask for changes to the paper to make it a better paper. And the ultimate aim of this exercise is really to communicate science. we want other scientists to benefit from the work of each other, and we want science and research to grow, and we want science to be communicated further than that. But it all has to start, at scientific journal level, and then it gets disseminated further out. And so that's the whole objective, I think, of publishing a scientific paper. So I suppose to answer the second part of your question, do I need to know a lot of information? I would say yes. It's not really possible to be an editor or a reviewer if you don't know very much about a subject. So the subject sometimes can be very broad, but most of the time it's fairly defined. So you have people that say have expertise in a particular area. So, for instance, phages, and then I'll get papers on phages to review and or edit.
Wow, that's a really, really big process.
Yes, it can take months. Frustratingly for the scientists who have written the paper, it's a horrible wait, to be honest. But the process is long because it does involve quite a lot of time and effort, and it's a team effort. It's not just based on one person's opinion, but it's based on a group of people's opinion, and so it does take a longer time.
Yeah, it must be annoying for the authors.
Yes, I think they find it a bit nerve-wracking.
Mm-hmm. What if my work doesn't get through?
I know, and actually that can happen quite often, as many of my papers aren't successful the first time I submit it to a journal, and then I just have to try again. And I think that being a scientist makes you more resilient in a sense, because you learn to accept failures quite positively. You sort of go, okay, that didn't work out. That's all right. I'll improve on it. I'll fix it, and I'll try again.
What made you choose to enter the field of microbiology? What did you want to be as a child?
That is actually a really difficult question. I would have to be very honest and say that I probably entered the field of microbiology just through trial and error. I had never heard of microbiology before I studied it at university. So that as an occupation had never occurred to me as a child. And when I was at university, I studied many different subjects, and I really enjoyed microbiology. I think that had a lot to do with the lecturers that delivered the subject. They made microbiology very interesting, and they explained very clearly how microbes, and in particular bacteria, can affect so many areas of our lives. I know that I focus quite a lot on human infections because that's sort of the area that I work in, but bacteria are also very useful in many different ways. Like they help make different types of food, like cheese and bread and wine, and yogurt. All of those food processes involve bacteria. Without bacteria, we would not be able to have such nice food. And soy sauce is also, I think there's some bacteria in it. So, and the other thing is bacteria also affect the environment. They can break down a lot of very toxic products and turn those into food for other higher organisms. So I realized that that bacteria were incredibly interesting. Also, fungi. Mushrooms, for instance, and the mold that you see, those are fungi. They cause diseases as well. And parasites can cause horrendous infections. And of course, viruses. So we've just, we still are almost at the tail end of a pandemic that's caused by a microorganism. It's a virus. And I just felt that microorganisms that are so small, and yet they can have such a huge impact on the world, and something that humans are still coming to grips with, that can, uncontrollable in so many ways, is absolutely worth studying, because they can in some ways determine our existence. So I think I definitely entered the field of microbiology because I felt that it had a very huge impact on humans and the world and Earth. And with regards to what I wanted to do when I was a child, I think I mostly just wanted to be good at something. It didn't matter what it was that I wanted to be good at, but everything that was put in front of me to do, a very simple task like cleaning up bean sprouts. My grandmother used to ask me to help clean up bean sprouts. I would do it to the best of my ability. And I always felt very happy when she said, "Oh, you did a very good job cleaning up the bean sprouts." So, I never really had a defined sort of, occupation, I think, or goal to be when I was a child. I just wanted to do the best that I could in everything, that I had to do.
Yeah, that's very inspiring. Yeah, I don't know what I'm gonna do yet.
I think that's totally normal. And to be honest, it's very difficult to predict what's going to happen in the future. And there might be some jobs that, will be available in the future when you are all grown up, that's not in existence now. So I think the best thing is just to keep your mind open, and it's okay if you don't really know what you want to do now, because I'm sure that you will discover something that you really like as you get older.
Yeah, yeah, yeah. I think I find something. I will find something.
Mm-hmm.
What are your hobbies?
Well, I really like reading. I love reading science fiction, and I like to read crime novels. I think the reason why I like to read these types of stories is because scientists are a little bit like investigators. So we're always trying to solve a problem. So I find the process of investigating a crime very interesting, because it's like a problem solving exercise, very much like being a scientist where we're trying to solve a problem. And science fiction, I really love it because science fiction authors have such fantastic imagination of uh, futures and universes based on science, and most of the time it's based on physics and mathematics, and these are two areas that I know very little about, so I like to read about them. The other thing I really enjoy doing is exercising. I find that helps me to relax, and so I like to go for a little jog around the block, and sometimes I go on my exercise bike for a little while. And I guess finally, I really like listening to music. It also helps me to relax. And I love listening to my son play the cello. My son is learning to play, well, he plays the cello. And whenever he plays, I love listening to it because it sounds wonderful to my ears.
Yeah, that sounds really nice.
Thank you.
Thank you so much for coming on my show.
You're most welcome. It's been a real pleasure.
Yes, I really learned a lot and enjoyed it a lot.
So, can I ask you some questions?
No, sure, you can ask me questions.
Okay. So I suppose I wanted to ask you, so how many of these interviews have you done?
120 something.
Really? Wow, that's amazing. Oh, gosh, you must be a real professional at it by now.
I wouldn't say professional. Let's do it.
So, after the recording, I'm guessing that there's a lot of work that comes after that to put together your podcast.
Yes, so after the interview, it's the editing that my father does, and then we make the thumbnail for the interview,
Mm.
and then we post it on the podcasting website, and then we which spreads it to like Apple Podcasts and Spotify and other
Wow.
places like that. And then we post it onto my website, and yeah.
Mhm. Wow, so it's a real family effort then. Your mum and your dad are also involved.
Yes, yeah. My
Yeah,
editing, my mom does the thumbnail, and I do the interview.
that's amazing. So, can I ask, you know, given that you sort of have this sideline, it's not really a sideline. I know you do it because you enjoy it. But what do you think you might do when you grow up?
I don't know. I have like 120 plus things on my mind.
Yeah. Yeah, I'm sure you do. And
So
how old are you? How
I,
old are you?
I'm 9.5.
Oh, wow. You are so very young, but very, very, very curious and very clever, I think. And I think that's such an amazing quality. And you should try and hold on to this quality for as long as you can, because that's going to be the key to, learning lots of new things.
Yeah, I will. Thank you.
Oh, so other than these podcasts, what are your hobbies?
I like building Legos.
Such as? Do you have a favorite series?
No, I don't have a favorite series. I like all of the big Legos. So like I just sold a lot of my Legos, and like I have right now I only have the really big ones, like the not the really big Millennium Falcon, but the big Millennium Falcon.
Wow.
And I have the Mini Cooper,
Ah,
a drag racer, and
yes.
I have this really big Porsche 911 Turbo. Yeah.
Wow. That's amazing. My son used to love to build Lego too when he was your age. And we have lots of Lego, and he also really liked Star Wars series. But we used to live in a very small house, so we never really had the space for the very big Legos. So we tend to have the smaller ones. But yes, Lego is really, really fun to build. It's actually quite relaxing, I think.
Yes, it's really.
Do you enjoy school in Singapore?
Oh yes, I enjoy it a lot.
Yeah. Okay, that's good. You don't find it too pressurizing?
No, I don't. And I also learned the drums. Yeah,
Oh, that's really good. I'm glad.
like I like drumming. I like listening to music. I like doing Legos. I like reading. I like watching TV. I like doing everything. I like playing sports.
What sports do you play?
So I know how to play cricket, but I don't play it that much.
Mm-hmm.
I play football a teeny little bit,
Mm-hmm.
and I do swimming,
Good.
and scootering and running.
That's fantastic. Yeah, it's good to keep active. Very
Yeah.
good.
Yeah. Okay, so thank you for coming. I really enjoyed speaking to you.
You're most welcome, and thank you for having me.
Yes, I learned a lot.
Oh, I'm glad.
Dear listeners, follow my Facebook page, Curious Vedant, to get updates on my upcoming episodes. To listen at leisure on your phone and get notified about future episodes, subscribe by searching for Curious Vedant wherever you get your podcasts, such as Apple Podcast, Spotify, Stitcher, Google Podcast, and many more. You can also listen to my show on curiousvedant.com. Thank you for listening to Curious Vedant, and don't forget to rate and leave comments.